Hello, everybody. My name is Dave Argent, and this is my talk called Confessions of a Systems Engineer, Learning from 20 plus years of failure. So let's get started with a little bit about who I am. My name is Dave Argent. I've worked at Amazon for the last 3 years and change and spent a long time in the tech industry before that, having been at Microsoft for 19 years, where I wore various hats from tech writer to systems engineer to SRE lead to program manager. And during that time, I've made my share of mistakes and watched even more being made. So I feel like I'm in a good position to understand some of the more common mistakes you can make when designing and operating a large-scale online service. At Microsoft, I worked for, among other departments, Bing, and at Amazon, I'm part of the team which runs, depending on who you're talking to, the largest NoSQL database in the world. So learning from failure. A few quotes from people who are probably smarter than I am. Develop success from failures. Discouragement and failure are two of the surest stepping stones to success, and that's Dale Carnegie. It is fine to celebrate success, but it is more important to heed the lessons of failure, by Bill Gates. Don't be afraid to fail. Don't waste your energy trying to cover up failure. Learn from your failures and go on to the next challenge. It's okay to fail. If you're not failing, you're not growing. And any talk in which I can quote Yoda is obviously a good one. Failure, the greatest teacher is. That said, when possible, learn from other people's failures as well as your own. And yeah, it's a picture of the Titanic in the middle of sinking. And I imagine you've all probably watched the movie and know how that ends. So here we have 20 odd years of wisdom from my failures. And in short form, we'll go over each of these. There are no safe changes. Minimize the blast radius, monitor accurately and measure, automate, anticipate failures and prepare, use functional gates basically everywhere, design to meet your SLA and mitigate incidents quickly, regularly exercise your processes and tools, enforce with technology, redirect traffic aggressively during incidents if you're geo redundant. Tools used to maintain a service must be production quality. Sanitize and verify your input data. Understand the scenarios you support, and transition service responsibilities carefully between groups. So that said, let's get into the meat of it. There are no safe changes. Any change is a potential incident waiting to happen, whether it's because processes change, whether it's because your code release is buggy, whether it's because dependencies aren't dealing well with something that you've just released, whether your automation has failed, whether you've got human error, and then if that wasn't enough, you've got the rest of Murphy's Law to account for. Another element about there being no safe changes is that code is as important as config, is as important as data. Depending on your service, any of them can kill you. And be especially aware of cross-environment contamination in configs. You may have default values where changes may apply to multiple environments, and not all test changes stay there, especially if you're using those default values. So the key take home here is treat all changes with care and respect. And no matter what it is, whether it's code, config, or data, any change is dangerous to your service. And I can point to an example from Bing where there was a config change, which was only supposed to apply to a test environment, and it ended up fanning all the way outward, taking out prod services when a VIP was introduced to the production config that was not designed to handle the production load. So minimize the blast radius on changes. Well, if changes are dangerous, then you need to figure out how to assess risk and make it so that your changes, which are kind of a necessary evil, are less dangerous. So in order to minimize the blast radius, you stage changes to progressively larger audience. You stage it to a small subset in a single DC, then to a full DC, and then outward. That sort of thing can allow you to redirect traffic completely from a dead data center at any point if you're geo-redundant. Also, if you've got zero traffic currently on a data center, it'll enable you to break the glass and do faster rollbacks and take much more aggressive actions because you're not worried about customers who are actually hitting that data center. So you can do a lot of breaking work that would otherwise be visible to customers if they were there. The other element on especially when tracking deployments is that positive validation is absolutely essential. A lack of negative feedback is not the same as success, because sufficiently broken systems may provide you with no feedback, leading you to believe that they were successful when they weren't. So in the real world, do a canary under deployment, as little range as you can, then gradually up the blast radius as you have more confidence in the release. And I'm pretty sure that most of the people listening to this have had a global deployment kill far more of your service than depending right to, because you didn't minimize the blast radius when you had a chance to. So the key lessons out of this: risk reduction is a key to successful change management. You want to minimize the audience of chances and then ramp up. And you really have, and since speed and agility are business requirements, but they also entail risk. So you should have speed and agility balanced against risk as a conscious trade-off, as opposed to just hoping for the best and crossing your fingers. And lastly, can't repeat enough, a lack of negative feedback cannot be your only signal that it is safe to proceed. You have to hear that, yes, it worked. Otherwise, you have no guarantee that it did. Moving on, monitor accurately and measure thoroughly. You need to be able to understand your service during normal operation. Without understanding normal, it is almost impossible to figure out predictably what's broken unless you're hard down. And incomplete failures are a fact of life. You don't want to be victim to them. So as a result, you need to monitor accurately. But more than that, you need to reduce false alarms to avoid unnecessary escalations. Otherwise, you're going to burn out your engineers, who are going to be suffering from sleep deprivation because they're getting paged in the middle of the night every night. You want to be able to direct escalations quickly to the person who can mitigate the issue when you actually have a real problem, because that's really the key to reducing your time to mitigate these sorts of incidents, is being able to direct it to the faulty, to direct it to the owner of the faulty component quickly. And you want to make alerts informative enough to point to the underlying problem or problems quickly, because let's face it, most failures seem to happen at about 3 in the morning, and most of us do not do our best work at 3 in the morning. And being able to read a document or being able to read through an alert that points us in the right direction is definitely a shortcut in terms of making, in terms of mitigating things more quickly. So really, your key lessons here: you can't know what's wrong if you don't know what right looks like. And you can't automate a response to something if you can't programmatically see where there's a problem. And direct escalation to the right person with enough hints or information to help them debug the issue if your automated mitigation fails is going to make your engineers happy, because they're not going to be awake all that often for long periods of time trying to debug issues off hours. And it'll also lead to faster mitigations. One last element here, you can think about it this way, and I've heard it said: just about the worst thing that can happen to you if you run a large online service is for your customers to tell you that you had a problem that you didn't know about. Think about that carefully. If you're at all concerned with your customers telling you that you have a problem because your monitoring missed it is really something you want to avoid. It's definitely a black eye. So I mentioned automation before, and I'll mention it again because it's quite important. You want to automate your mitigations. Not all failures are hard down issues. You want to be able to build systems which are able to self-diagnose a wide range of failure modes, whether you've got a bad server and need to fail away, whether you're running a stateful service and need to change who owns the database in terms of a multi-cluster system. There's a whole lot of things that you need to be able to self-diagnose a wide range of failure modes. And what's more, you want to be able to try to repair those failures and performance issues proactively before the customer gets a chance to notice. For example, if you've got a top-of-rack switch that fails, you want to have your system find that those servers are not accepting traffic and automatically fail over elsewhere. Better yet is if you need to add additional capacity, automatically add additional capacity out of a spares pool. You want to keep human beings out of the loop as much as possible because it's faster. And because your resolution times are going to be shorter than the amount of time that you can page an engineer if you've automated it correctly. You also do need to be aware of your dependencies and you need to be able to react to their failures. Anytime you take a dependency, design for the idea that it's going to fail because it will. So understand what your response has to be when something you depend on fails so that you can act accordingly. And again, preferably without human input because speed matters and anything you don't have to page an engineer for is an engineer doing something that is more productive to you, at least potentially. So really it boils down to step 1, measure it. Step 2, determine what's wrong. And step 3, automate your mitigation moving forward. The key lessons here: no human being can react as quickly as a system that can diagnose itself accurately and take its own corrective actions. Accurate monitoring and self-diagnosis of problems is key because if you can't diagnose the problem, it's very difficult to automate a solution to mitigate that problem when it arises. You need to be able to react to partner or dependency issues, and that can be as important as reacting to your own. Basically, you don't have control over all of the things that you depend on, and yet you're still stuck operating a service and trying to hit some number of nines worth of availability. You can't do that if your partner, if your partner or your dependency isn't sufficiently reliable and you don't have a plan for dealing with that. And lastly, MMA, measure, mitigate, automate. Next up, degraded service modes, otherwise known as an imperfect experience is usually better than a non-existent one. At some point in time, if you are running an online service for long enough, you'll be unable to serve all of your traffic or a dependency will fail. You don't want to have to figure out what to do when it happens. You want to have tested standard operating procedures, SOPs, in place for what to do when it happens. You don't want to have to improvise a solution during a crisis. That is literally the worst time you can possibly come up with a solution. If you can possibly figure out a way to deal with it beforehand, test it, get all of your engineers familiar with it, you have a much greater amount of a security blanket and you'll usually handle outages much better and more gracefully. You do need to protect yourself from overload because serving some customers is better than serving no customers in most cases, which means you need to have ways to shed excess load, whether that's at the network level, whether that's at the load balancer, whether that's some sort of load shedding mechanism. You need something because you can't rely on your partners or your customers to self-limit load. While you may have partners that are fairly good at this, relying on them is almost a guarantee, thanks to Murphy's Law, that eventually they won't. And certainly, customers are not well known for self-limiting load. And as a result, a kind of a sad state of affairs, but something which is nonetheless true in the real world, is that customers and partners are often the enemy of service availability. Just because they're your friends or they're giving you money doesn't mean it's their job to make your service more easily operable or that they're going to self-limit things like load. So the result of all this is you really need to plan for failure. You need to work to provide your customer with a useful experience even during failures. So really, the key lessons here are understand and design degraded service modes into your system for if a component breaks, what does your customer experience look like and how can you make that the best customer experience that's available given the failure that you currently have in your system? And test those degraded modes and the SOPs that surround their use. And I'll give you a very painful example on this one. Some of you may have been familiar with, Prime Day 2018. At its worst, one of the main databases was responding to 98% of all requests, and that was when it was absolutely at its worst. Despite this, it still made front page news for major site-wide availability issues from what is actually a relatively small overall availability loss. So what happened? Upstream partners didn't keep the idea of degraded service modes in mind. And as a result of that outage, there were more postmortems than I can count on both hands in terms of lessons learned there. So use functional gates pre, post, and during releases. And I'm going to point to the side of one of the pictures that I was so proud of finding, which is a gate that you can simply walk around. That is not a very functional gate. So good is testing before you deploy. Better is testing after you deploy as well as before you deploy. But the best is really testing during your employment while you're in the middle of increasing the blast radius, so that you can test it when it's got the smallest available audience, and then test some more as you increase the audience until such a time as you've completed your rollout. This enables you to catch issues early, and it also enables you to proactively roll back while the blast radius is small and while you have fewer customers that might notice that you have a problem. So that said, testing is great, but if you have useless functional gates, it's not going to help you all that much. So you really want to test and monitor your actual service functionality, and then you want to be able to accurately measure the real customer experience. And this is an occasion where sometimes synthetic tests are adequate, but a lot of times they're not. Because if you're dealing with purely static data, it can get cached. There's any number of things that can happen where synthetic tests simply don't reflect the real world, and where a customer might see a problem, your test might not. You're also going to want to have specific monitoring against your canary environment, which is what I'm calling the first place that you ever deploy something, your smallest blast radius. And you also want to have specific monitoring against individual fault domains. You don't want to say, for example, alert at 99% availability for across the world and discover that that meant that one of your small regions was hard down with 0% availability. You really need to have individual fault domain monitoring, because just doing your stuff global and hoping that all of your failures are evenly distributed isn't going to hold in the real world for a lot of cases. So be aware and be careful. So key here, test before, during, and after your deployments. Look at and monitor the customer experience and have monitors that are specific to your fault domains. I ran into a bug back in the days of yore when I was working at a startup called Web TV. It went production, and they did their first attempted register of a new customer, and it replied with a window which was a word I probably can't say during this presentation. It turns out that there was a file which had a list of excluded words that couldn't be part of a username, and there was a white space in front of it, which meant it matched everything, and the error message turned in to the excluded string that you couldn't use. So the net result is monitoring is fairly important, and you need to exercise the entire customer experience, because saying, oh yeah, the normal path an existing customer would use works. Well, if you haven't monitored new customers, you may have a problem, so be aware. Design so that you can actually meet your SLAs and mitigate your incidents quickly. You need to be aware of the limitations of your service and its dependencies, because it's really hard to design a single DC 5 nines service when the power to a single DC is only good for 4 nines. You need to understand your SLA requirements. Designing for 5 nines is both a lot harder and a lot more expensive than designing for 3, and there's no sense in ever designing for 5 if 3 is what you actually need, because you generally don't have an infinite budget. I know I don't. But if you're smart about it, you can design yourself to be better than the sum of your parts and dependencies. You can use caching strategies to reduce the impact of dependency failures. You can utilize your redundancy to reduce or eliminate the impact of a data center failure. The ways in which you can actually be better than the sum of your parts, there's too long a list to actually mention here. So this list isn't exhaustive. That's just designed to give you some ideas. But the net result here is really you just need to design with failure in mind, because it's going to happen. Mitigations for your known failure modes, you can't have them break your SLA. This often means that you have quick rollback options available, and sometimes it means that you're going to end up being stuck with a redesign. Availability can be better than the sum of its parts if you design well. And you need to understand your failure modes and how long they take to recover from. If a common failure takes you out of your SLA, you have a redesign ahead of you, and redesigns are an awful lot less fun than the first design is. They also tend to cost a lot more. So giving an example from a major search engine, there was a bad data push, which forced a full index rebuild because they didn't have the tools necessary to remove the bad parts of the data from the push. So as a result, they had bad search results for several hours, during which time it took to rebuild the entire index. They didn't design with the idea of mitigating an incident like this quickly. They didn't build the tools that were necessary to delete bad data selectively. They were forced into a full rebuild in a long process. So these things actually do hurt in the real world. Regularly exercise all of your processes and tools. Welcome to America, where you've got a picture of a 24-hour fitness and everyone's on the escalator. We don't like exercise, or at least a lot of us don't, and I'm guilty of that as much as anyone else is, and probably more than many. That said, an unverified backup is worse than no backup at all because it gives you a false sense of security. It lets you believe that you have an actual backup and that if something goes wrong with your main database or your main data source, that you can recover from it. If you aren't doing disaster recovery exercises, how are you going to have confidence in them when you need them? You really have to test your disaster recovery in the real world, and preferably you're testing it not during the crisis incident, which actually is where you need it most. Another thing, especially if you're dealing with large services, starting cold is not anywhere near the same as starting warm. So if you've got customers who are hammering at your door, can you actually get your service up and running before all of your backed up traffic that might be potentially hitting you overwhelms your service and rips it down again? Can you limit the traffic enough to allow yourself to get back up on your feet? Again, an example from Prime Day 2018. Recovery took longer than it needed to because we couldn't discard traffic which the client was already timing out and ignoring. So we were spending a number of our precious CPU cycles in a relatively overloaded system doing work which was useless. And we didn't have good ways to throttle away that particular type of traffic to help us get back up on our feet again. So key lessons here. An SOP that you don't run regularly can't be relied on. It just can't. If you haven't run it within the last 3 to 6 months, things could change out from under you. You may not have had practice. There may be a new engineer on call who's never seen it happen before. There are too many things that can go wrong if you don't regularly run them. Recovery from hard down is often very different than recovering from a partial outage. It's basically retry storms and all sorts of similar things can happen to you where you start bringing your service back up from a bad failure and then you just get swamped by having too much traffic. So you need to have processes which will allow you to bring up your service despite any amount of traffic that might be hitting its front door. And as a result, you really need to design your build your tools and build your processes, and they need to all work together to protect a service during a cold start. Cold starts are potentially the most dangerous thing, and also since a cold start is usually indicative of my service is hard down, they are usually the worst failure to the customer. As a result, you want to get yourself back up the fastest. So ideally, we're enforcing processes with technology because humans make mistakes. We're imperfect. I'm imperfect. I've certainly made a lot of mistakes over a long time, both at work and at home. So it's good to have processes in place to try to help reduce human error. But the better solution is to have technology in place so that human error simply can't occur. You want to make the right way the only way that you can normally execute an operation, because let's face it, a really good syseng type person or a really good ops person, let's assume that they do 99+% of everything correct. By the time you've got a 50-step process for something like a manual deployment, more than half the time, something will go wrong. So you can't have unrealistic expectations of how accurate human beings can be because we make mistakes. So if you make the right way the only way you can normally do it, the potential for human error goes down an awful lot because you can test all of your code ahead of time and you can work to make it bulletproof, and you remove human error from the equation. That said, you need to be able to allow for high risk actions, which are often referred to as breaking the glass. You've all seen the, in case of emergency, break glass. That's what I'm talking about here. So having good guardrails for being able to only do it the right way is the enemy of flexibility during an incident. Since you can't predict all incidents, you can only try your best. You need to balance the ability to improvise and potentially respond to that risk by requiring break glass operations to require two-person authentication, or to have some sort of guardrails for, yes, I realize this isn't the way we're supposed to be doing it. Yes, I know what I'm doing, and require extra confirmations so that you can't accidentally do things other than the normal way without meaning to. So really, account for human error. You can't avoid it. Make the easy way both the right way and the only typical way. Another element of that I should probably add is make it the easiest way. So lastly, understand when you need to take the guardrails off of your lovely system that stops human error with solid SOPs to help protect you from yourself, because when the guardrails are off, you really have the potential to be your own worst enemy. Now, this doesn't so much apply to non-geo-redundant services, but if you're dealing with clusters, the same principles sort of apply, which is redirect or drop traffic aggressively during incidents. And really the idea here is that an outage that the customer might not notice is usually better than one they will definitely notice. A slower, less complete experience is generally greater than no experience at all, and service to some of your customers is usually greater than service to none of your customers. So don't be afraid to redirect aggressively if a fault domain is underperforming. High latency or small availability drops can and often should justify redirecting traffic, because low service quality impacts brand as well as impacting the bottom line as well. That said, you really need to have objective criteria for what constitutes unacceptable service. It has to be well defined. You don't want to be determining what acceptable service quality is during an incident and have to make judgment calls. During an incident is not when you want to be making judgment calls if you can possibly avoid it. So really the key lessons here is react such that some service is usually better than no service. Minimize the impact of the customer, decide ahead of time whether full service to some is better than degraded service to many, and write your SOPs, your tools, and your processes accordingly. And remember that not all damage from an outage is from lost transactions. Brand ends up being rather important for companies, say like Amazon or Microsoft or Facebook or any number of companies that are really trading on their brand to ensure their own success. Production quality tools. Any tool that you depend on to operate your service must itself be of production quality. Incidents have a tendency not to come on a convenient schedule, and no one really wants to have to answer for when your tools only mitigate 99% of incidents and you hit the 1%, which takes you down for 24 hours because your tools weren't ready to deal with it, or your tools were down. So administrative tools can have a massive impact on service. They rarely have the same rigor of test coverage, and especially for things like disaster recovery tools or very seldomly used tools, they are infrequently exercised and are even less frequently tested. Most of the time, I've worked on a lot of services where the administrative tools were not part of the standard test suite. They just didn't have test coverage. So you never knew from one release to the next whether the administrative tools were still going to work. So really, you want to treat your administrative tools as mission critical because during an outage, they are, and outages will happen. You need to exercise those tools regularly to ensure that they're ready when they're needed, and that your documentation is up to date, and that your SOPs for using them are up to date. And you really want to test your tools prior to every release. And by that, I mean in your test environments. Discovering that the tools you rely on to operate your service don't work with the latest release is awkward when that release has fanned out to all of production. So just as an example of production quality tools, imagine, if you will, that your control plane, which is responsible for replacing dead hosts, has a single point of failure and it doesn't fail over its master correctly. This might have happened to me in the real world on a couple of different occasions. It's a bad scene. You really want to have your tools be production quality. And that includes monitoring them, just like you would be monitoring production. Sanitize and verify inputs. I was thinking about an X-Files graphic here for trust no one, but I really think that you also need to stay paranoid, and that just wasn't going to be complete enough. So really trust no one, because any data can be bad, and this is despite the best intentions of whoever's giving you the data. It could be a partner who doesn't want to do anything bad to you, but if they have an error somewhere or someone fat fingers a piece of manual input, bad things can happen. And you really have to assume that all services that are communicating with yours will make mistakes. Malformed data isn't your friend, it's your conjoined twin that you can really never be rid of. Malformed data will happen, it will find its way to your service, and it is up to you to ignore it and treat it appropriately, generally with prejudice. Everyone is a potential enemy of your service quality, including and especially yourself, because frequently you're the one providing yourself with your own data, or you're doing your own data processing. Any bug in a parser can potentially result in bad data that gets thrown into your systems. And if you don't sanitize and verify the inputs when you're doing between system calls, you make yourself vulnerable to bad data coming in. So design assuming that invalid data or requests will hit your service early, often, and regularly. It doesn't even have to be people with ill intent. It can be people who just simply make a mistake. Service configuration should receive extra validation because a bad config parse can easily result in a complete service outage. I might have seen that one happen a couple of times, where you push out a new configuration, your service bounces as part of picking up the new configuration, and suddenly your service won't restart. You combine that with not having a good blast radius on pushing your configuration changes, and suddenly you're hard down, and it's not necessarily easy to get out of that. Understand all the scenarios you support. For example, at Amazon, it's not all just US retail. We have to be concerned with a worldwide operation. So you need to understand who you are serving and what are their requirements. Understand what traffic is important and why, because this can guide how you react during incidents. If you have to remove traffic from your service, as part of a load shed, if you understand what service is high quality service to you or what is high import service to you and what isn't, you can make intelligent decisions about what traffic to drop. For example, I can tell you, Bing classifies certain traffic just based on how it looks as whether it's highly likely to be bot traffic or not. If the system gets overloaded, it will selectively drop bot traffic first, just as a useful example of how to treat traffic in effectively different tiers. You also want to avoid cross-region dependencies so that you can isolate your fault domains, because few things are worse than having one central item, which is the linchpin to your entire worldwide service that's not replicated anywhere, and have that go down. If you have that component replicated across all of your fault domains, then you're not prone to a worldwide outage for that one issue. You're only going to potentially hit the one fault domain which isn't currently receiving that data. That said, having a failback in a different region can be a very good idea, such that if your local version of something isn't available, that you have somewhere else that you can look for it. It's basically protection by layers. So really, you want to design with data and service segregation in mind. Avoid having one region's issues degrade service elsewhere. That doesn't mean that you have to have a complete wall between them, but you need to make sure that a problem in one place doesn't hurt anyone else. And you really need to know that not all traffic is created equal. If you have the option to drop low priority traffic during an adverse event, that may be your best option. Additionally, in recovery, if you can recover your high priority traffic first during an adverse event, that's also going to be very good for your business. So it's really about understanding the scenarios, understanding the types of requests that you're getting, and treating them with the import they deserve when you can't serve everything. Lastly, transition service responsibilities carefully. You should be constantly planning for transitions because this doubles as preparation for adding new team members. Tribal knowledge is the enemy of all things good in the world. Document and exercise your SOPs. Use your SOPs during every incident. Your documentation will remain up to date that way, or the diffs between documentation won't require someone to do a multi-month slog through your knowledge base to figure out what is and is not stale. This enables safer transitions of responsibility between groups. Also, take advantage of shadowing existing staff during incidents for training opportunities. Nothing teaches you how to operate a service quite as well as watching somebody else operate a service or peeking over your head, while you're in the process of operating a service. So off to the right, you might imagine there was once a copyrighted image here, which showed that tribal knowledge is the enemy if a member of your team leaves the realm of living suddenly and unexpectedly. You can guess what cartoon that might have been. So key lessons here. It takes effort to run a service well. It also takes effort to teach someone else how to run a service well. Document all the things. And a good handoff is a two-way transaction. Merely saying that a transition is complete is not the same as meaning that it will be effective. So I got a couple of parting thoughts here. Hopefully you haven't fallen asleep just yet. But no list like this is exhaustive. These are just some lessons from a long career spent operating online services. Some of them are obvious, some of them are less obvious. Think about tomorrow, next month, and next year about what you'll need to operate your service at scale, because once you fall behind on scalability, the technical debt to catch up can be very difficult to surmount. Prepare and design for success. One of the most dangerous times for a service is when it's embarrassingly successful. It's a problem you want to have, but it's a problem you need to be afraid of and plan for. And lastly, mistakes will happen. Things will break. The best way to learn and improve is not to concentrate on assigning blame, but to work together on solutions to avoid similar situations moving forward. And put another way, more succinctly, have your postmortems be blame-free rooms. Blame doesn't help you. Working towards solutions does. Thank you for your time, and I hope you can learn from an awful lot of the mistakes I've made instead of learning the hard way yourself. Thank you for listening.